Good morning students. Now we discuss about the example 7.7 second problem subdivision 2. You see the questions, find the local extrema for the following functions using second derivative. This is the question. So now we discuss about the exercise 7.7 second problem subdivision 2. The question is find the local extrema for the following functions using second derivative test. Now so this is a given function f of x equal to x log x. I write it f of x equal to x log x. Next I take the first differentiation. So differentiate with respect to x. So f dash of x equal to, there is a two functions x and a log x. So I apply the uv method, uv into dv plus v into du. So first function I write as it is x into, I differentiate the log x. Differentiation of log x is 1 by x plus next log x I write it, and next first function I differentiate the x. Differentiation of x is 1, so x cancelled, therefore f dash of x equal to 1 plus log x. This is the f dash of x. So the next step I take f dash of x equal to 0. So f dash of x equal to 0 means 1 plus log x equal to 0. So I write this plus 1 in the right hand side, so it comes to minus 1, sign change. So plus 1 right in the RHS means minus 1. So the next step, now I taking the exponential on the both side. So exponential of log x equal to exponential of minus 1, e power minus 1. E power log x equal to e power minus 1. So exponential and log cancelled. So x, I write it x equal to e power minus 1. So next e power minus 1, there is a, you see the power, there is a minus. So I write this term in the denominator. So 1 by, because numerator minus, numerator is minus power means I write in the denominator it is a plus power, so 1 by e, therefore x equal to 1 by e. So this is the critical point, therefore the critical point is x equal to 1 by e. Next I calculate it. So now we found the critical point, x equal to 1 by e. Next now I calculate f double dash of x. So f double dash of x means, so I differentiate the, again second time I differentiate the first derivative. So again this is the first derivative, f dash of x equal to 1 plus log x. Now I differentiate the second time, so differentiate with respect to x. So f double dash of x equal to, first I differentiate the 1 is a constant, so we differentiation of 1 is 0, so I write it 0 plus differentiation of log x. Differentiation of log x is 1 by x. So therefore f double dash of x equal to 1 by x. This is the answer for second derivative. So x equal to 1 by e is the critical point. Now I substitute this point in the function f double dash of x. So f double dash of x equal to 1 by x. So 1 by x means here x is the 1 by e, I substitute, so 1 by e. So therefore this 1 by e I reciprocate, so e by 1 into e by 1 means e. So e is a positive, so positive means greater than 0. So the answer is, the f double dash of answer is greater than 0 means, so we take that point is a local minimum, therefore x equal to 1 by e is the local minimum, therefore f of x has the local minimum at x equal to 1 by e. So now we find out the local minimum value. Local minimum we find, that means f of x has the local minimum at the point x equal to 1 by e. Next now we calculate the local minimum value. Local minimum value is, we substitute f of 1 by e equal to that means we know the f of x equal to x into log x. So x is a 1 by e, log of 1 by e. So therefore 1 by e into log of 1 by e equal to, and then in this step I write it 1 by e into, that means I write the log 1 minus log e, because log 1 minus the denominator right before we multiply by minus, so log 1 minus log e, so equal to 1 by e. We know the log 1 value, log 1 equal to 0, I substitute, minus log and e cancelled, so our answer is 1. So 0 minus 1, therefore 1 by e of minus 1 equal to minus 1 by e. So this is the answer, this is the local minimum value for f of 1 by e. This is the local minimum value for f of x. Therefore local minimum value equal to minus 1 by e. This is the answer. So f of x is the local minimum at x equal to 1 by e, and the local minimum value is minus 1 by e. So next, third subdivision, f of x equal to x square into e power minus 2x. So I write the given function f of x equal to x square e power minus 2x. So now I differentiate the given function with respect to x. F dash of x equal to, now I write it x square into, I differentiate the e power minus 2x. So I differentiation of a base, so e power exponential is the e power, that functions I write it. Now I differentiate the power minus 2x. Differentiation of minus 2x is minus 2 into differentiation of x is 1. So e power minus 2x into minus 2 plus, now e power minus 2x I write it, and now I differentiate the first term, first factor x square. So differentiation of x square is 2x. Therefore I write it minus 2 into, that means f dash of x equal to minus 2 x square e power minus 2x plus e power, that means 2x into e power minus 2x. Now I write the common factor. Here common factor is 2 into e power minus 2x. This is a common factor. So 2 into e power minus 2x. So I take the every term from 2 into e power minus 2x. So I take the 2 into e power minus 2x from the first term. So 2 I take out, and next e power minus 2x also I taken. So remaining factor is, remaining term is, that means minus x square. Next 2 into e power minus 2x I take from the outside. So remaining term x. Therefore f dash of x equal to 2 e power minus 2x into minus x square plus x, or other if this is not needed, you just keep it as it is. F dash of x equal to minus 2x square e power minus 2x plus 2x e power minus 2x. You keep it as it is, no problem. You don't take the any common term, anything. Next f double dash of x. F double dash of x equal to 2 into, again there is a 2 function. One is e power minus 2x, second function is, next function is minus x square plus x. Now I differentiate. Now I take the first factor is 2 e power minus 2x, I write as it is. Now I differentiate the second term, second factor minus x square plus x. I differentiation of minus x square is minus 2x plus differentiation of x is 1 plus next minus x square plus x into differentiation of 2 e power minus 2x. I write it 2. Differentiation of exponential is, I write same, e power minus 2x. Next you differentiate the power. So minus, differentiation of minus 2x is minus 2. So the next step, 2 e power minus 2x plus 1. Next 2 2s are 4. So minus 4 e power minus 2x minus x square plus x. The next step, now we take the common factor. Here common factor is 2 into e power minus 2x. So 2 into e power minus 2x into remaining factor minus 2x plus 1. Next 2 and e power minus 2x I take from the second term. So remaining factor minus 2 into minus x square plus x. So next step, f double dash of x equal to 2 e power minus 2x into minus 2x plus 1. So minus into minus plus 2x square minus, again minus 2 into x minus 2x. So minus 2x minus 2x. So we add. So minus 2 e power minus 2x minus 2x plus 1 plus 2x square minus 2x. Now I adding the terms, 2 e power minus 2x into 2x square minus 2x minus 2x minus 4x plus 1. This is the f double dash of x. Now we find out the critical point. So critical point we consider f dash of, we need the critical point is, the condition is f dash of x equal to 0. This is the condition for critical point. So f dash of x equal to 0. Therefore 2 into, now I take the f dash of x equation. F dash of x equation is 2 e power minus 2x into minus x square plus x equal to 0. In the next step there is a 2 factor. One is 2 e power minus 2x. Second factor is minus x square plus x. So 2 e power minus 2x equal to 0 minus x square plus x equal to 0. So e power minus 2x equal to 0. Here I take the common factor. Common factor is plus x. So plus x I take from these two terms. So x into, that means I take the 1x. So remaining factor minus x plus I take the 1x from this term. So remaining term 1. So therefore x into minus x plus 1 equal to 0 and e power minus 2x equal to 0. So next so minus 2x, next e power minus 2x equal to, that means in the previous step now you see this is e power minus 2x equal to 0. Now I take the log on both sides. So log of e, log into, that means log e into, that means log of e power minus 2x equal to log 0. So log and e cancelled, so our equation is minus 2x equal to log 0 is 1, so minus 2x equal to 1. So from this equations I taking the log on both side, e power minus 2x equal to 0, I taking the log on both side. So that means e power minus 2x equal to 0, so I taking the log on both side. So log of e power minus 2x equal to log 0, so log and exponential cancelled, so minus 2x equal to log 0 is infinity, so x equal to infinity, that means x equal to this minus 2 right in the right hand side, so infinity by minus 2 infinity. Therefore x equal to, next second factor, x into, that means I take the common x, so from the equations, so x into minus x plus 1, so equal to 0 means x equal to 0 and minus x plus 1 equal to 0, so x equal to 1. So therefore we got that infinity we cannot take the value, so we take the value x equal to 0, x equal to 1. Therefore the critical points are x equal to 0, x equal to 1. So therefore, because already infinity in the number line, so next so at x equal to 0 I substitute in the second derivative, f double dash of 0 equal to 2 into e power 0, 2 into 0 minus 4 into 0 plus 1. So therefore e power 0 is the 1. So next this are all first term 0, second term 0, remaining 1. So 2 into 1 positive equal to 2. So f double dash of 0 equal to 2. 2 means it is a greater than 0. Greater than 0 means therefore x equal to 0 is the local minimum. So f of x is local minimum at x equal to 0. Next f of 0 equal to, so next now I calculate the local minimum value. Local minimum value is x equal to 0. So x equal to 0 means f of 0 equal to 0 square e power minus 2 into 0. So the answer is 0. This is the local minimum value. Therefore local minimum value is f of 0 equal to 0. Next I substitute x equal to 1 in the second derivative. So f double dash of 1 equal to 2 into e power minus 2, 2 into 1 square minus 4 into 1 plus 1. So in the next step f double dash of 1 equal to 2 into e power minus 2, so 2 minus 4 plus 1. So the next step, third step, 2 into e power minus 2, I add all the numbers. So 2 plus 1, 3 minus 4 minus 1. Therefore now minus 2 e power minus 2. So f double dash of 1 equal to, we get the answer minus 2 e power minus 2. Minus means it is a less than 0. So less than 0 means it is a, that means x equal to 1 is a local maximum. Therefore f of x as local maximum at x equal to 1. So now we find out the local maximum value. So I substitute x equal to 1 in the function. F of 1 equal to, the function is, that means we know the functions, I substitute x equal to, that means so I write it 1 square e power minus 2 into 1. So e power minus 2 in equal to e power minus 2, I write it in the denominator, so 1 by e square. So this is the local maximum value. Therefore local minimum is 0, local maximum value is 1 by e square. Next third problem, for the function f of x, small f of x will come here. So small f of x equal to 4x cube plus 3x square minus 6x plus 1. Find the intervals of monotonicity. So next local extrema, intervals of concavity and points of inflection. So now we find out the intervals. After that local extrema, we find out the answer for local extrema. Next we will find out the concavity and the point of inflection. So first I write the given function. This is a small f of x, not capital F of x. So I write it the given function f of x equal to 4x cube plus 3x square minus 6x plus 1. Next I differentiate this function. So differentiate with respect to x. So f dash of x equal to 4 into differentiation of x is 3x square. 4 3s are 12x square plus 3 into differentiation of x square is 2x, 3 2s are 6x minus 6 into differentiation of x is 1, so minus 6. Therefore f dash of x equal to, now you see here every number is a multiples of 6, so I take the 1 6 from the each term. So I write 6 from the first term I take the 1/6 from the first term. So 12 factorize into 6 into 2, so I take 1/6 from the 12x square, so remaining factor is 2x square plus 6x, so I take the 1/6 from the second term, so remaining factor x. Next third term, I take 1/6 from the third term, so minus 1. So therefore f dash of x equal to 6 into 2x square plus x minus 1. Therefore f dash of x equal to, you factorize this, that means you write 2 into minus 1 minus 2, so minus 2 plus 1, so you take the number minus 1 plus 1, so you multiply minus 1 plus 1, that means you take the numbers, you factorize this. So therefore now that means I factors this 2x square plus x minus 1, I multiply 2 into minus 1, 2 into minus 1 is minus 2, so I take two numbers and multiply two numbers, I get the answer minus 2, and I add that same numbers, I get the answer plus 1. So I choose the number minus 2 plus 2 minus 1, I add the minus 1 plus 2, I get the answer, that means I multiply, I got the answer minus 2, and I add that two numbers, I get the answer plus 1. So I factorize this equations, I got the factor 6 into 2x minus 1 x plus 1, or otherwise you just keep it as it is. This the first term is also enough, that means f dash of x equal to 12x square plus 6x minus 6, this is also enough. You don't take the common factor from this, it's not enough to me. Okay, so this just you keep the first step also it enough to we calculate the f dash of x, that means critical points. Therefore f dash of x equal to 12x square plus 6x minus x, this is the differentiation answer. So next f double dash of x means you just 12 into differentiate the x square, differentiation of x square is 2x. Next 6 plus 6, so 24x plus 6, so 24x plus 6 you keep as it is, no. So next 24 plus x plus 6, you take the 6 from the term, so the remaining factor is 4x plus 1. Therefore f double dash of x equal to 6 into 4x plus 1. So now we find out, you see the intervals, they ask about the intervals and local extrema, so now we take f dash of x equal to 0. So f dash of x equal to 0 means you take the 12x square, that means 6x, 12x square 6x minus 6 equal to 0. Already we factorize this, f dash of x equal to 6 into 2x minus 1 x plus 1. So I substitute here 6 into 2x minus 1 into x plus 1 equal to 0. So 2x minus 1 equal to 0, x plus 1 equal to 0. Therefore 2x equal to this minus 1 I write in the right hand side plus 1. So x equal to 1 by 2. Next x equal to minus 1. Therefore the stationary points are, now I take the stationary point, that means x equal to minus 1, x equal to 1 by 2 are the stationary point. So I mark it in the intervals because they ask about the interval, so I take the number line minus infinity to plus infinity, I mark it the critical points, that means these also critical points. So minus 1 plus 1 by 2 I mark it here, first minus infinity to minus 1 it comes the first and next positive answer, so 1 by 2. Now so I write the interval minus infinity to minus 1, minus 1 to 1 by 2, next 1 by 2 infinity. So this is our interval, that means minus infinity comma minus 1, 1 minus 1 comma 1 by 2 and 1 by 2 comma infinity. These are these three intervals for this problem. So now I take the time turn, that means tables, first intervals column, next now I take the, that means intervals, so intervals are minus infinity to minus 1, minus 1 to 1 by 2 and next 1 by 2 infinity. So I take the factor, here the factor is x plus 1 2x minus 1, that means f dash of x, I take the f dash of x factor, x plus 1 2x minus 1. So I substitute any number, I take any number, suppose I take the minus 1, x equal to minus 2, I substitute here, so minus 2 plus 1, so our answer sign is minus in the answer, so minus. Again next x equal to minus 2, so 2 into minus 2 minus 4, minus 4 minus 1 minus 5, so sign is minus. So next minus into minus plus, therefore f dash of x sign is plus. So plus means the monotonicity is increasing, so increasing function. So minus infinity comma minus 1. Next again second interval minus 1 comma 1 by 2. So I take the minus 1 comma 1 by 2 means I take the, that means middle value is x equal to 0. I substitute here x equal to 0. So you take any between values from this interval. So I take the between values x equal to 0. So I substitute in the factor 0 plus 1 1. So answer is positive sign. So plus. Next I substitute x equal to 0 minus 1. So minus 1 means negative sign. So minus, plus into minus, minus. Therefore it is a decreasing, strictly decreasing. So next on minus 1 comma 1 by 2. Next 1 by 2 comma infinity, you take the any values between this interval. So 1 by 2 means after that I consider 1 2 3 4, it goes on. So now I take the simple number x equal to 1. So x equal to 1 I substitute here 1 plus 1 2. So 2 means it is a positive answer, so I represented plus. Next x equal to 1. So 2 minus 1 1. So it is a positive answer, so plus. Next I multiply plus into plus plus. So f dash of x sign is plus. So f dash of x sign is plus means it is increasing on 1 by 2 comma infinity. So from this table I conclude the answer. F of x is strictly increasing on minus infinity comma strictly increasing on minus infinity comma minus 1 and 1 by 2 comma infinity, and strictly decreasing on minus 1 comma 1 by 2. Therefore since f dash of x, now we change the sign. That is, you see in f dash of x as the sign changes, plus into minus, minus into plus. So f dash of x changes from positive to negative. So positive to negative when passing through x equal to minus 1. Therefore positive to negative means we take the local maximum, negative to positive means we take the local minimum. So f dash of x has the sign changes from plus to minus, so it has the local maximum. Therefore f of x has local maximum at x equal to minus 1. Therefore f of minus 1 equal to, I substitute the x values now. So we know the local maximum at the point x equal to minus 1. Now we find out the local maximum value. So f of minus 1 equal to 4 into minus 1 whole cube plus 3 into minus 1 whole square minus 6 into minus 1 plus 1. Therefore equal to minus 1 whole cube is minus 1 plus minus 1 whole square is plus 1 minus 6 into minus 1 plus 1. Therefore minus 4 plus 3 minus into minus plus 6 plus 1. Therefore you see f of minus 1 equal to 6. Therefore local maximum value is 6. So next since f dash of x changes from negative to positive, so first we see f dash of x changes from positive to negative, so it is a local maximum. So negative to positive means it changes the sign, it has the changes the sign negative to positive. So negative to positive means it has the local minimum, so at the point x equal to 1 by 2. Therefore f of x is local minimum at x equal to 1 by 2. Now I substitute this value in the f of x. So f of x I substitute x equal to 1 by 2. Therefore f of 1 by 2 equal to 4 into 1 by 2 whole power 3 plus 3 into 1 by 2 whole square minus 6 into 1 by 2 plus 1. Now 4 into 1 by 2 whole cube means 1 by 8 plus 3 into 1 by 2 whole square means 1 by 4 minus 6 into 1 by 2 plus 1. Now we cancel that means 6 and 2 divide the 6, the answer is minus 3. So minus 3 plus 1. So in the next step 4 and divide cancelled. So 1 by 2 plus 3 by 4 minus, that means minus 3 plus 1 is minus 2. So equal to, now that means I take the LCM. LCM is 4. 4 in the denominator I take the LCM 4. So you see the first term there is a 2 only. Now I converted this denominator into 4. So multiply and divide by 2. 2 by 2. So already there is a 2. 2 into 2 4. So 2 by 4. The first term I converted into 2 by 4. So 4 here. The numerator I add it. So 2 plus next you see the second term there is a 4. So only numerator only we add. So numerator value is 3. So plus 3. Next you see the third term there is no 4 in the denominator. So we multiply and divide by 4 by 4. So minus 8 by 4. Minus 8 by 4 means already 4 in the denominator. So minus 8 you add in the term. So minus 8. 2 plus 3 5. 5 minus 8 is minus 3 by 4. Therefore this is the local minimum. So local minimum value is minus 3 by 4. So local maximum equal to 6, local minimum equal to minus 3 by 4. To find the intervals of concavity and the point of inflection. Now we find out the concavity. So f double dash of x equal to 0 means 24x plus 6 equal to 0. So the next step, 24x equal to this plus 6 I write in the right hand side, so minus 6. So next 4x, that means I cancelled the 24 by 6, so 6 4s are 24, so 4x equal to minus 1, therefore x equal to minus 1 by 4. So next so now x equal to 1 by 4, x equal to 1 by 4 I represented, that means, so now you see here x equal to minus 1 by 4 I represented the number line is started from minus infinity to plus infinity, so minus 1 by 4. So the interval is minus infinity comma minus 1 by 4 minus 1 by 4 comma infinity. Therefore the intervals are minus infinity comma 1 by 4 minus 1 by 4 comma infinity. So now I take the any number from this interval, so minus infinity comma minus 1 by 4. So that means I write it f, that means f double dash of minus 1 equal to 6 into 4 into minus 1 plus 1 equal to, that means 6 into minus 4 plus 1 minus 3, so minus 18. Minus 18 is the less than 0, so less than 0 means it is a concave downward. Again I take the minus 1 by 4 comma infinity, I take the between values one value, x equal to 0 I take from this, so x equal to 0 I substitute in the f double dash, so 6 into 4 into 0 plus 1 equal to 6 into 1, it is a positive, so it is a concave upward. Therefore the curve is concave downward is minus infinity comma minus 1 by 4, the curve is concave upward is minus 1 by 4 comma infinity. Therefore the point of inflection are at, so that means we substitute the any value from this interval, the answer is f double dash of answer is less than 0, so I mention it concave downward, and any interval from any value from this interval I substitute in the f double dash, I got the answer greater than. So here I take the x equal to minus 1 from this interval, I substitute in the f double dash, I got the answer minus 18 is less than 0, so concave downward. Next x equal to 0 I substitute here, so I got the answer, that means positive greater than 0 concave upward. Therefore the curve is concave downward on minus infinity comma minus 1 by 4. So next the curve is concave upward, it is a minus 1 by 4 comma infinity. So the point of inflection, now we find out the point of inflection, f double dash of x equal to 0. So already x equal to minus 1 by 4, so x equal to minus 1 by 4 I substitute in the function f of minus 1 by 4 equal to, so throughout the function I substitute x equal to minus 1 by 4, so f of minus 1 by 4 equal to 4 into minus 1 by 4 whole cube plus 3 into minus 1 by 4 whole square minus 6 into minus 1 by 4 plus 1. Therefore minus 1 by 4 whole cube means minus 1 by 64 plus 3 into minus 1 by 4 whole square means 1 by 16 plus minus into minus plus 6 by 4 plus 1. So the next step, now I just cancelled 4 into 64 minus 1 by 16 plus 3 by 16 plus 6 by 4 plus 1. So therefore that means I take the LCM 16, so the numerator is minus 1 plus 3 plus 24 plus 16, I add all the numbers, so we got the answer 42 by 16. That means minus 1 plus 3 is plus 2 plus 2 plus 24 26 36 plus 6 is 42, so 42 by 16. So again, so I cancel the numerator and denominator by the same number, so that means 2, so I cancelled 42 by 2, so 21 by here 2 8s are 16, so 8, 21 by 88. Therefore the point of inflection, is y equal, this point we take y equal to 21 by 8, therefore minus 1 by 4 comma 21 by 8, this is the inflection point. So in this questions they ask about the, that means intervals, and next local extrema, next concavity, next point of inflection. So we find out all the answer for this question. we complete the class.